Then when I get the same answer, 8 minus 2 is what? Now when I get 6/10 instead of getting 18. Now in reality, this is what we're going to end up using. I mean, this is great to do that with, but the problem is if I'm giving you numbers from like 3 to 455, you don't want to be doing check marks. Everybody with me? So look on your formula sheets and find me your formula for OR. All right? This is the first one we're going to do is the formula for OR. All right? So the probability that you have event A or B. So look what the formula says. It's the probability of just event A all by itself like you did, plus the probability of event B all by itself. But we've got to worry about the double counting. So we're going to have to subtract the probability that we have A and B. Now in math, when it says and in this formula, it means at the same time. So when we get the probability of getting an even number or a number greater than 7, we need the probability that it's just even. That's my A, my first event. We need the probability of the second event, B, that it's a number bigger than 7. And then we need both at the same time. That it's an even number and it's what? Bigger than 7. So you were right. There were 5 numbers out of 10 that were even. And then you were right. We counted 3 numbers that were bigger than 7. And then I've got to stop and think, which numbers were even and bigger than 7 at the same time? So 8 is even and it's what? Bigger than 7. What other one? 10 was even and bigger than 7. So that's why I'm taking off 2 out of 10. And so I end up getting 8 minus 2 is 6 out of 10. So I get 6/10 or 3/5, depending on whether you like a decimal or reduced fraction. Okay? Now, with that said, let's talk about this. All right. A deck of cards. Now, I'm not going to teach you to do 5-card stud poker, okay? But the deck of cards do come up in the book some, and they come up on my test some. So we do need to know what's in a deck of cards. So like surely we played Go Fish on a band bus or something. But in case we didn't, let's review what's in the deck, because you're going to need to know it. All right? There are 4 pictures, for lack of a better word. I call them suits. All right? There are 4 suits in a deck of cards. What's one suit in a deck of cards? Hearts. All right. What's another one? Hearts what?
Clubs.
Clubs. What else? Spades. What else? Diamonds. All right. Now, some of those are red and some of those are black. Which ones are red?
Hearts and diamonds.
The hearts and diamonds are red. And the clubs and spades are black. Do you know how many cards are in a deck? 52. You're going to need to know that. So how did you take your calculator and figure out how many hearts are in the deck? What can I do? All right, you got a calculator, so find me how many hearts are in the deck. All right, so everybody's the calculators out. You're going to be using them. How many hearts are in a deck? 13. So there are 13 hearts and 13 diamonds and 13 clubs and 13 spades. 52 divided by the 4 gives me 13 of each. How many cards are red? 26. Half of them are red, 26, half of them are black. Now, they talk about face cards. All right, face cards are the ones that have what they think of as a picture on it. So if your book or my test talk about a face card, they're talking about like a jack, a queen, or a king. So how many face cards would be in the whole deck? 12. Because I would have a Jack, Queen, and King of Hearts, and a Jack, Queen, and King of Diamonds, and a Jack, Queen, and King of Clubs, and a Jack, Queen, and King of Spades. So each of these has a Jack, a Queen, and a King. So there's a total of 12 face cards in the whole deck. All right. Now, what numbers are on the cards? What's the first number what's the lowest number you might see actually on the card? 2. What's the biggest number that's on the card? 10. So I've got 2s, 3s, 4s, 5s, 6, 7, 8, 9, and 10. Now you also have an ace. Okay? So you've got to know what's in that card. So you got your formula for OR, right? So I want you to go find this for me. What's the probability that you get a king or you get a black card? And I'm going to let you pick one card. All right, so you got a deck and you shuffle the deck up, okay? And you're drawing one card out, and you're going to win if it's a king or a black card. So find me your chance of winning. Now, again, when you're working, I can't give you any credit for what's going on in your head, only what's on the paper. So what I have found every single time is when somebody starts getting lost and I'm helping them, I ask to look at their work from their homework. And every single time, the words that come out of my mouth is this: you're not doing enough writing of words. So there should be a lot of writing of words before you ever start putting numbers on your paper. And you get in the habit of doing it now, otherwise you're going to get lost when the problems get more complicated. So what do I mean by that? Here's what I mean. On my formula sheet, it says this: the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So when I've written this on my paper, I'm going to do this. So the probability of a king or black is the probability of just the first one, which is a what? King, what? Plus the probability of just the second one, which is what? Black. Minus the probability of both at the same time. So it's got to be a king and it's got to be what? Black. That's a lot of writing of words. I'm not putting numbers yet. Because it's really like working 3 problems in one problem. And so I've got to focus on the one problem that I'm working, the one piece I'm working at the time. So all I'm doing is the probability of getting a king. And what always goes on the bottom of probability? The total. What's my total with a deck of cards? 52. This what's in parentheses goes on top. It can't go on the bottom because it's going on top. How many kings are in the deck? 4. Because I've got a king of hearts, a king of spades, a king of clubs, and a king of diamonds. All right, plus. Now, it's like starting a whole new problem. I want to know when you pick one card, what's the chance it's black? And what always goes on the bottom of probability? What's my total? 52. Of those 52 cards, how many are black? 26, very good. Minus. Now, it's like starting a whole new problem. What goes on the bottom of a probability? The what? You're tired of hearing me say it, the total. Now, I need to know what cards in the deck are king and black both at the same time. How many are there? There are 2. The king of clubs is a king and a black card. And what else? The king of spades is a king and a what? Black card. So it's like working 3 separate problems in one. So this writing of words helps you focus on the one piece that you're doing. Now, do I need a common denominator when I'm adding and subtracting fractions? I do. So I've got one. So my common denominator is 52. So I do 4 plus 26 is 30. 30 minus 2 is what? Now, is that simplified? No. I can either change it to a reduced fraction or I can change it to a decimal. What will go into both 28 and 52? 4. So I can divide them both by 4 and get what? 7 what? 13th, or I can go to an approximate decimal, 3 or 4 places. Now, what number do I not want you rounding to? 0, and don't round to what? 1. So you can go 3 or 4 decimal places as long as it doesn't force you to round to 0 or 1. Otherwise, if it does, you got to go further. Okay? So is everybody okay on that one? Now, the other thing the author likes a good bit is he likes tables. And to me, these are really easy with a table because you can physically circle things and see them. Now, what do I mean by that? Let me show you what I'm talking about. So you need to learn, if you don't know what's in a deck of cards, you need to learn it. Okay? Because I'm not going to tell you on a test. All right, so what if we had this? Suppose I gave a test and some people made A's and some made B's, some made C's, some made D's, and some made F's. Okay, suppose I decided to look at male and female. And this is what I found out. Because that's the makeup of the grade distribution right there. All right, I'm going to randomly pick one person, like a name. And I want to know what's the probability that this random person made a B. So you go find me that. All right, so I've got my table down there, and I want to know the probability that somebody made B. Now, what always goes on the bottom? What's my total in this one? 20 what? Don't joke, got 2 different answers. All right. That's going to be 10. 5 and 5 is going to be 10, so it's 24, isn't it? All right. So my total is 24. How many made a B? 10. So I said that these made a B, all these made a B. I've got 6 guys that made a B, 4 girls that made a B. Now, why can't I leave it 10 over 24? Because it's what? It's not reduced. So if you put 10 over 24, we'll get it wrong. So what fraction can you put? What would both those divide by? 2, so I can put 5/12 If you don't like decimals, you can put approximately equal to and tell me point what, 4, 1, would it be 6, 6 or 6, 7? What's it gonna round to? 7. If you put 6, 6, I'm gonna count it wrong. We never chop off, we round off. Okay? All right, do this one for me. What if I put that person back and mix them all up again? And now I want the probability that the person is female. I mean the probability that if I just randomly select a name, like a person off the list, that they happens to be a female. What goes on the bottom? 24. Why? Because it's what? The total. All right, females go on the top. How many females are there? Because you had to add them all up, right? There were 12. So again, you can either change that reduced fraction 1/2, or you can change it to a decimal 5/10. But what if I said this? What's the probability that the person was female or made to be? Female or made to be. So think about your formula and write down all the pieces. All right, so does everybody understand? I want the probability that it's a female. And what do you do with or? Do you multiply, add? What do you do with or? You add. And the probability of just the second one, so they made a B. And then mine's the probability of both, so they're female and made a B. So it's like 3 different problems. So if you want partial credit, that's what I need to see. So it's like starting all over. What's the chance they're female? We said a minute ago there are 24, and of those, how many were female? 12. It's like starting all over. All right, total always goes on the bottom. So 24 of those, how many made a B? We said there were how many? 10. Now here's what's lovely about a table. Do you see that when I was working the other two, I'm going, okay, how many were female? And I did all of these numbers and added all of those up, and I got the 12. And then I said, okay, how many made a B? So we went and looked, and these are the ones that made the B. So that's where we got the 10 out of 12. So when I get to this last part, which says minus the probability of both, out of my 24, do you see I can see the physical overlap? What number got double counted? The 4. The 4 is in the purple, oval, and it's in the red oval. So I've got to take off that double counting. So I've got to take off that 4 out of 24. So the table, to me, is really easy because you can physically circle things and see what gets double circled. So I've got, what, 22 minus 4? So what was your numerator originally? 18. Now, again, I can't leave it like that. All right, so I can either take my calculator and go over here and say 18 divided by 24. And again, you need to round, so that gets point what? 75, or you could reduce that to 3/4, whichever you prefer. Okay, but so to me, tables are nice because you can physically circle and see what gets double counted. Now, do this one more for me from that card, and then we're going to move on to a different connected word. All right, so let's do this one. All right. So again, you're going to pick one card from a deck. So I want you to do this one. I want to know the probability that it is a heart or a black card. Okay, the probability that it's a heart or a black card. All right, so I've got the probability of just a heart plus the probability of just black minus the probability of both at the same time. So what did you get for the probability of being a heart? How many out of the 52? 13. All right, what was your chance it was black? How many out of 52? 26. What was your thing on here?
0.
Why 0? Because it's not possible. Now, I don't care if you put just 0, if you put 0, 52, doesn't matter. And 0 divided by 52 is 0. There are not any cards that are heart and black at the same time because the hearts are what color? Red. Now, there's going to be a special name for that I'm going to talk about in a second. So I get what? 39 out of 52? So what did you get for your answer? 3/4. Again, if you like decimals, you can get 7,500. Now, the fancy word for this is mutually exclusive. All right? Mutually exclusive events. They are events that cannot happen at the same time. All right, mutually exclusive events cannot happen simultaneously. They cannot happen at the same time. Now, your book has two different formulas. Okay? Your book would say that the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. And then it's got a separate formula. The probability of A or B is the probability of A plus the probability of B. And it says that use this formula when it's mutually exclusive and use this formula when it's not mutually exclusive. Do you really need two formulas? No. This first formula works all the time. It's just when the events are mutually exclusive, what's this answer going to be? But it didn't freak anybody out to subtract 0. So you don't need 2 formulas, you just need what? 1 formula. But sometimes events are mutually exclusive. If you know one happened, the other couldn't have happened. Okay? All right, now, I want to start this. We're going to talk about it a lot more on Thursday, but I do want to kind of start with it. There's a different connecting word from or called and. Okay? So the probability of A and B. Now, when it says this, it assumes that A happens first and B happens second. So there's an order that's implied here. All right? Probability of A and B. Now, here's the catch. This is going to save you a lot of trouble later. When you're reading the problem and it says, what's the probability of A and B? The first thing I want you to ask yourself is this possible? I want you to ask, is this possible? Now, you're either going to get a no or you're going to get a yes. Now, here's what I mean. I'm going to let you pick one card. What's the probability that it's black and a heart? We talked about that a second ago. 0. Why?
Because it's impossible.
It's impossible. If you're picking one card, it can't be what? Black and a what? Heart at the same time. So if the answer to this question is no, what's the probability? 0. And you're finished. If the answer is yes, then I want you to use the and form. So I'll put that too. So is it possible? Here's the reason. This formula assumes you're doing more than one thing. So if you just do this, it will keep you from grabbing this formula when it was never intended to be grabbed. So I said pick one card. This formula does not apply because it assumes you're doing multiple things. Everybody with me? Now, I'm going to write your formula down and then we're going to kind of fix it in a second. All right? The probability of A and B is the probability of A times the probability of B. Now, let me show you what I'm talking about. What if I tell you that I've got a bag of marbles? And inside this bag of marbles, I've got 2 red ones, and I've got 3 blue ones, and I've got 4 green ones. And here's what I'm going to say. I'm going to let you pick 2 marbles. And I want to know what's the probability that you get a red and a green. What's the probability that you get a red one first and a green one second? So see if you can figure out what to do, because I gave you the formula. So what's the chance you draw and you get a red one, and then you draw and you get a green one? Now, let me ask you this. Is there anything that you need to know that I did not make perfectly clear that might change something? Because I would have a question. What's something you might need to know? Agree?
The order.
All right, the order. But this formula does assume that you're doing this one first and what? That one second. But you're right. If I just said, what's the probability that you end up with a red one and a green when you get a red first and a green second, or a red second and a green what? First. So if we're going with, you have to get a red first and a green second. What else have I not told you that might be important, Emma? Do I put the marble back or not? Because wouldn't that change things? So what I'm going to do on a test is I'm going to do it this way. I'm going to say with replacement, or I'm going to say without replacement. Because I'm not going to get the same answer. They're going to be close, but they're not going to be the same. So with replacement means when I pick it, I record what I got and I put it back before I pick the second time. So if I'm going to do the first one with replacement, does everybody understand? I'm going to do the probability that I get red the first time times the probability that I get green the second time. So what's the chance on the first pick that you got red? What did y'all have? 2 out of what? 9? Now, I'm assuming the marble is red. Now, what am I doing with this red marble? I'm putting it what? Back in the bag. So when I go back in the bag, how many marbles are in the bag? 9. How many of those are green? Are there 4? Now, do I need a common denominator when I'm multiplying? No, it's okay to have one, but I don't need one. But my bottom number is not 9. What's my bottom number? Is it 81? 9 times 9, and then 2 times 4 is what? 8. Now, if I don't know about decimals, that one's reduced. But if I'm not sure, if I change to a decimal, 8 divided by 81 would give me about 0.098. Would it be 8 or 7? 8. So either one of those would be okay. Now, look at the difference here. It's still the probability of red times the probability of green. On my first pick, what's my chance of getting red? 2 out of what? 9. Now here's what you got to do. We're going to talk about this more next time on Thursday, but you have to assume that the marble in your hand is red. Because if it's not, it's already game over. Now, what am I doing with this red marble this time though? Am I putting it back? No, I'm keeping it. It's gone. How many red marbles do I have in my hand right now? Just tell me. 1. Is everybody with me? So when I go back in the bag for my next pick, what's my total? It's 8. Of those 8, how many are green? 4. So this time I don't get 8 out of 81, I get 8 out of 72. Now that'd be 1/9. But again, if I don't trust myself with reducing, if I do 8 divided by 72, I get about 0.11111. Now again, those are pretty close to the same, but they're not what? They're not the same. So what you're going to have to do is know whether you're putting something back or whether you're not putting something back. Now your author sometimes will say you pick 2 different marbles. When he says different, that's his way of saying without replacement. What if I told you that you were going to get 2 blue marbles? You pick 2 marbles, what's the probability they're both blue? Well, see, I don't see a connector word, but I've got to sit here and reason it out. What's the only way I would get 2 blue marbles? The first marble is blue what? And see, I automatically say, and the second marble is blue. So sometimes you have to reason out what your connector word is. They're not going to say, what's the probability that you get blue and blue and blue? They're going to say, what's the probability that all three of them are blue? Is everybody with me? Where's your homework going to be? We're going to start looking for the notification for that video as well. Everybody with me?